Thank you. I will not be outdone. I have a joke. Why are JavaScript developers never satisfied? Because they're always looking for closure. Hi. I'm Johnny. I work at Till as VP of Engineering in Washington, D.C. Till is building a platform to deliver financial inclusion in the rental housing space. If you want to learn more, talk to me afterwards. But today I want to talk to you about something different. I want to talk to you about a tragedy. It's about the death of the full stack developer. So what exactly is a full stack developer or engineer, or whatever you want to call it? Before we can answer that, I think we need to talk about, well, what stack are we talking about here? Let's rewind the clock back to 2005. This is right before jQuery hit. Front-end was pretty basic at that point, right? Browsers just didn't do very much, and they didn't have to, right? They were little more than document rendering machines, which is what they were designed for, and they did it very well. Front-end development didn't really consist of much more than form validation and maybe some dynamic CSS stuff every so often. Fast forward a year in like 2006, if you could actually do some dynamic CSS toggling with something like jQuery, like you were hot shit. And that's just how it was. The back end was really where the magic happened, right? To be fair, it had to be because client-side technology lacked sufficient compute power to do anything interesting, at least by today's standards. If you were a back-end developer, you could go into the front end, do very minimal work, and really have big impact on the direction of your product. Sure, you had like system administrators and DB folks, et cetera, but these were seen as sort of like outside the role of a traditional developer. Fast forward to 2019. What does front end actually look like today? Well, you have HTML, CSS, and JavaScript just as you did at that time. With HTML5, now you also have native audio and video, multimedia capabilities in the browser. That's not too bad. You have multi-threaded programming with web workers. You have peer-to-peer communication with WebRTC, both with media and as well as data. You have event-driven communication between the client and the server with WebSockets, which enables a lot of things, you know, like real-time communication, things like that. You have responsive web development, the ability to be able to respond to different sorts of devices, and we'll talk about that very, very shortly. WebGL, you have 3D programming in the web. That's a whole nother world in and of itself, but today that's possible. You have offline capabilities. Notifications, unfortunately. Location services, which is a nice way of saying creepy GPS stuff, right? HTTP 2, and it moves fast, now HTTP 3, apparently. Webpack, which can just as easily be a stand-in for all of the front-end tooling there, and I literally don't have enough room on this slide to put all of those things. You can do databases in the browser. Transpiling, you can take one language and transpile it to JavaScript. You can also take JavaScript and transpile it to JavaScript. It's amazing. Data modeling, advanced state management, spas, frameworks, frameworks, frameworks. Bruh. In 2019, the browser is a platform. It's evolved way past the days when you're simply displaying what the server is telling you. It's much more capable than that. You can create client-side immersive experiences without ever really talking to a server at all. If you were to take a front-end developer from 2005 and then drop them in 2019 and say, go build a compelling front-end experience, they would drown in the complexity. Let's talk about mobile. In 2019, you cannot ignore mobile devices. According to the Pew Research Center, 96% of American adults own some sort of cell phone. Of that, 81% of which are smartphones. That's up from just 35% in 2011, which is when Pew first started collecting this data. Now keep in mind, this was 4 years after the iPhone had already come out. So it stands to reason that there was a spike to 35% from wherever it was prior to that. In 2005, mobile just wasn't a factor. Sorry, BlackBerry. Today, it's the overwhelming majority of users. At Till, over 70% of our users come from mobile devices. Mobile applications. With the rise of mobile devices came mobile applications, which added to the stack outside the context of browsers. It enabled us to access even more user context, to have better ideas of who our users were, what they were into, and the context of their environment. This was made possible by an array of sensors that came on the devices themselves. This also gave way to better performance, and now you have user expectations. People use their mobile devices constantly. I see half of you on your phones right now. Personal entertainment, including gaming, shopping, photography and video, which has largely displaced traditional cameras, and an occasional phone call. More and more mobile computing devices have become the primary computing device for a large number of consumers, particularly in the developed world. Mobile is part of the stack. The prolific spread of the devices throughout the lives of consumers have forced us to contend with this fact, but we don't really think about it as part of the stack. We say front end and back end, but we completely ignore where most of the users are coming from. If you're building a product today, you have to at least consider mobile, if not do mobile first. Wearables, not insignificant. Despite false starts with some wonky eyewear, wearables, particularly smartwatches, have become an important part of a small segment of the consumer base, and that base is still growing. Particularly with fitness. They have less computing power and are less capable in general than their mobile phone counterparts, some even needing a phone to even be fully functional, but they have a strong following and companies investing in them. As of this presentation, I think it was just announced like a week ago that Google just bought Fitbit, right? That's a strong indication of how serious corporations are taking this technology. Internet of Things. This is basically just a catch-all of anything that's not a wearable or a smartphone or whatever, right? You have innovations with human-computer interaction. Speech technology is the one that comes to mind the most. It's not new technology, but it's gotten really, really great with the rise of machine learning. Screenless speech-based interfaces are now the norm. Just as a generation of children grew up with touch becoming a major computing interaction, thus making it second nature for them, so will a new generation of children do the same with regard to speech input. Desktop, still a thing. The point here is that the client is not basic anymore. There are platforms, multiple platforms that are stand-ins for the client. Let's go to the back end. Well, I won't recount all of the innovations that have happened on the back end. I think it's sufficient to say that we have much better abstractions. Containers. Containers have essentially revolutionized the way we think about software delivery. As successor to virtual machines, they allow you to package not only your applications, but the desired operating system, well, at least the useful parts anyway, together to ship to production. It basically makes your operating system just another dependency declared with no more than a line of code. This allows developers to never have to worry about a deployment environment. Containers became the interface between local development and production, and essentially got rid of the whole "it works on my machine" conundrum, although I still run into that sometimes. Kind of weird. Many problems can be solved with a monolith deployed as 2 or 3 containers, your traditional application tier, database, etc. But when you need more and you need to scale out, you start to get into really hairy territory, right? And that's when you really need to think about how you orchestrate your applications. I was going to tell a story about that, but I'm going to skip it. I don't have that much time. Non-trivial applications often require many different components: caches, secondary databases, messages, queues, things like that. And of course, you can package each of these within containers and deploy them into production, and things can go like really, really well. But the knowledge required to effectively coordinate these components, ensuring things like uptime, redundancy, SLA/SLO, adherence, monitoring performance, this all really becomes a domain all its own. And it used to be its own job. But with the rise of DevOps, the line has been blurred between who's writing code and who's running things in production and monitoring it. Many companies have strict cultures of ownership. Anything you put into production is yours to monitor and keep up at all times. This level of operational excellence requires yet a whole nother set of skills. Containers gave us a great interface and common primitive for shipping software. But that, combined with user expectations of always-on software, left a hole in the universe for working with the ever-expanding complexity of modern software development. This gave way to some great orchestration solutions which solve many of these problems, but still require a certain level of expertise to wield them. Abstractions have gotten better, but it's still not good enough. We have to go higher. Serverless. Now, I was a huge serverless skeptic for a very long time. And I will embarrassingly show you just a few of my tweets that sort of like illustrate where I was just a couple years ago. Serverless is a prime example of an abstraction taken to its extreme. Not only is it useless, but it's misleading without tons of context. AI streaming data platform built on top of functional reactive serverless microservices. Serverless blockchain-powered Russian bot generator. A few red flags: zero config, self-described visionaries, serverless. And my personal favorite, your serverless tool. I was wrong. Turns out, the ability to distill your application down to its core pieces, which is the business logic, the value that you actually need to create in order to generate revenue, is monumentally better than actually worrying about shipping servers. And when you really think about it, it's absolutely ridiculous that we've been doing it, that we've gotten away so long without having this paradigm come into play. I'm not going to give an absolute definite definition of serverless. It's a little bit too murky. It's some combination of Lambda-type functionality coupled with servers that aren't managed by you, that scale up and down whenever you need them, blah, 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 blah. You know it when you see it, right? For example, you don't write a server which accepts HTTP requests. You tell the internet to that you expect an HTTP server to be there for it, listen to certain endpoints, and that other infrastructure should respond when that happens. And that's really all it is. The rest of the paradigm works very much the same way. It's quite a pattern: no servers, no containers, just value. As a manager with a budget, this is music to my ears. Data. ETL. Today, the world runs on data. Data is used to solve tons of problems, but moving data, transforming it, managing it, securing it, has become its own competency. Now companies want data engineers, and you can't really blame them. Most data scientists I've ever worked with personally all have the same complaint. They spend way too much time data wrangling and not enough time doing actual data science-y stuff. If ML is your solution, before you can solve any business problems, you have to solve a data problem first. So, what's a stack in 2019? Well, there's the browser, the platform, which includes all the mobile browsers and all the capabilities that come along with that. Mobile applications and the array of sensors and distribution that come with it. Wearable technologies, smartwatches, goofy glasses, Internet of Things, and all the accompanying HCI innovation. The desktop, still here. Traditional backend applications, web servers, container-based applications, and the corresponding technologies and orchestrations required actually to run that in production. Serverless, and all of the accompanying infrastructure and declaration DSLs along with it, although we've seen earlier that there's some promising tools and frameworks to kind of help us out with that. Now what? You may be saying, well, you talk a good game, this is all true, but what the hell does this have to do with me? I'm a full stack engineer. It says so right here on my LinkedIn page. You know, this is my thing. You know, don't rain on my parade, bro. Well, all right. Brace yourselves. I'm about to get very manager right now. I'm not really one for management fluff. These things tend to not work out in practice, from my opinion. But I think there is a quote that is attributable to either Colin Powell or Ben Horowitz. It depends on what you read on the internet, which is that you should hire for strengths and not for lack of weaknesses. When you say you want a full stack engineer today, what you're really saying is you want someone with no real weaknesses. You want someone to climb up and down your stack, expertly solving problems which are very complex and in many times very specific to that level of the stack. One could realistically do this about 15 years ago pretty easily. Today, when you consider what the stack really is, it's not only unfair, but it's impossible. I am not unreasonable. Budget is a thing. If you're just launching your business and you can only afford one engineer, then sure, get someone who can add as much value in as many places as possible, but understand that there's a limit and you're gonna hit that limit as probably sooner than you think. If you want to build world-class products, you need engineers doing world-class work, and that means specialization. You have to think about how to scale your hiring needs alongside your product needs. You shouldn't try to build an engineering organization of 20 or more with all full-stack developers. That doesn't even make sense. You need to be specific about your needs. There's a temptation to just throw bodies at a problem, put out a post for a full-stack engineer, and just take whoever checks most of the boxes. All engineers know that there's a point of diminishing returns, after which additional people just do more harm than good. If you know what you need, you can be smarter about the people who you bring onto your team and making sure you're leveraging their strengths in order to add value to your product. Focus facilitates growth. You get really good at something when you have an opportunity to do it for a while. The number one mistake I see junior engineers make is jumping from one thing to another way too quickly. I have a mentee who was learning to code very recently. And one of the first things they were learning was Node, which is great. But then I reconnected with them the following week. Then they were like learning Kubernetes. And I was like, wow, that's a big jump there. Then a week later, they were diving into Vue, my personal favorite front-end framework. But then got worried because they also needed to learn GraphQL. It's not their fault. Companies put this pressure on people all the time, and they feel they need to learn it all in order to keep up. Otherwise, their jobs are going to be at risk. Where the hell are the juniors? It's hard out here to be a junior engineer. I don't envy anyone at the beginning of their software engineering career today. The universe is expanding faster than the speed of light. If you've been a developer for 10+ years, you've been expanding with the universe because you were there at the big bang of complexity. If you're starting out today, you're starting from 0, and the speed limit is the speed of light. You just can't catch up. We make it extremely difficult for less experienced engineers to break into the industry because of the unrealistic expectations and the rapid rate of change. Now, I don't believe in hard and fast rules. This approach is not for everyone. I do consider myself a full-stack developer, but I have that privilege because I've been doing it for a while. But I think that we should realign on our expectations when we bring people into the industry and when we bring them into our organization, such that we're setting them up for success and therefore creating a much more equitable and inclusive industry for anyone to come in and let their strengths shine. Thank you.